Let's build a box. Okay, we're going to construct a box with an open top. So it's just going to have the bottom and the four sides. And we're going to start with a 30 by 30 inch piece of cardboard. So let's draw that. So we've got a square piece of cardboard that we're going to use. Okay, and it's 30 inches on each side. And what we're going to do is we're going to cut out squares from each corner. And then once those are gone, we'll have these four flaps, and we're going to fold along these flaps, fold them up, and that'll make the sides of the box. Okay. So the question is, with this piece of cardboard, we want to make this box as big as possible. So the question is, how much do we cut out of each corner in order to maximize the volume? All right, so here we go. We know we've got 30 on each side. Let's write down here at the bottom. Question is, how much do we cut out of each side? So let's call that X. And we'd actually have this all the way around the box. We're going to cut little X pieces all the way around, only we don't know what that size is. So, to maximize, we're going to do the volume. Well, the volume of the box is the length times the width times the height. Now, if you can visualize this, when we cut this X distance away and fold it up, X is going to be the length of each of these sides. So the height of the box is going to be X. The length and the width will be these distances right there. That'll be the length and that'll be the width. And it's going to be the same on each side. Now, how long is this side? Well, we know the whole length down here is 30. So let's start with the 30. But we know it's going to be shorter than 30 because we cut off some of it. Well, how much of it did we cut off? X on this side, X on this side. So it's going to be the 30 we started out with minus those two X pieces. And we're going to have the same thing on here because we start out, this would be 30 on each side minus those two X pieces. So the length is going to be 30 minus 2x. The width is going to be another 30 minus 2x. So we just, instead of writing it a second time, let's just square this one. Okay, so there's our formula for the volume. Now, we need to multiply this out because if we want to maximize the volume, it means we're going to need to take a derivative and find a critical point. And in case you're wondering, that shadow was my cat jumping on the table, not really aware that I'm shooting a video, so apologize for that little thing. He just wanted to be part of the action. And if I don't hurry, he will be part of the action. So let's continue. All right, we need to FOIL this out. Okay, so I'll leave the X by itself. If we FOIL this out, we're going to have 30 times 30. That's 900. We're going to have 30 times minus 2x and another 30 times minus 2x. So that's going to be 2 minus 60x's. We combine that together. That's minus 120x. And then negative 2x times negative 2x would be plus 4x squared. Now, I left out the steps. I just talked through it. If you want to write this out twice, FOIL it out, and see that you do end up with this. Okay, so then we multiply by this x. And I'm going to rearrange the terms as I do it. So x times 4x squared, that's going to be 4x to the third. X times negative 120x is going to be minus 120x squared. And then finally, x times 900. 900x. All right, so there's our formula for the volume. And now if we want to maximize the volume, that means we need to take a derivative and find a critical point. So the derivative is going to be, we bring the 3 out front, 3 times the 4, 12. Reduce the exponent by 1, 2. Then the same thing, 2 times a negative 120, so that's going to be 240. x squared, reduce that by 1, we just have x, plus 900x is a linear term, so the derivative, we just drop the x. Okay, so there's our derivative. The critical point is when the derivative is 0. So we have 0 equals 12x squared minus 240x plus 900. Okay. Now to make this simpler to solve, let's divide everything by 12. That'll make the numbers a little smaller. You actually don't have to, but let's do it to make the numbers smaller. 12 divided by 12 is just 1x squared. Negative 240 divided by 12 is negative 20x. And 900 divided by 12 is 75. And so we have a quadratic to solve. Now, if you want to, you can use the quadratic formula with a equals 1, b equals negative 20, c equals 75. In my classes, I give them a quick way to do it because we're trying to do the calculus, and instead of spending time doing the quadratic formula, I've got a spreadsheet that they can plug the numbers in, or some of them have an app on their phone or a program on their calculator. At any rate, if we were to use the quadratic formula on this, we get two answers. X comes out to be about 21.5 and about 3.5. Okay, if we use the quadratic formula on those. Just take a moment to double check that. I'm sorry. That's not right. I must have plugged it in wrong when I worked it out earlier. We get 5 and 15. All right, so our x will be 5 and 15. We'll blame that one on the cat. He distracted me. Okay, so let's think about it. We've got two answers. Can both of them be right? Well, remember what we're trying to do. We're trying to determine how much to cut out of each side. Okay. Well, let's look at the 15. Does it make sense to cut 15 off of each side? Well, if I cut 15 off of here, and then 15 off of here, that's a total of 30. That would be cutting the whole edge of the box off. And if we cut the whole edge of the box, then we don't have anything left. So it doesn't make any sense. So we'll throw out the 15. So the only answer then would be 5. Okay. If we cut off 5 from each corner, that'll leave us with 20 along here, 20 along here, and then when we fold it up, 5. So our box will actually have a volume, or it'll be set up 5 by 20 by 20. Okay, 5 times 20 is 100. 100 times 20. So we would end up with a volume of about 2,000 cubic inches. Okay, so that's how you work one of those out. Apologize again for the miscalculation there. But there we go.